Hello and good morning. Let's start with another problem in continuous with your segment tree. So problem in name is Russian doll envelope. You are given 2D array of integer envelopes where envelope I is WIHI representing breadth and height of envelope. One envelope can fit into another envelope if and only if other both breadth and height of one envelope are greater than the other envelope breadth and height. Okay. The maximum number of envelope you can fit you can Russian doll. Put one inside other. Note you cannot rotate an envelope. So we need to put the one envelope into another envelope and continue this series till we reach its smallest envelope. So move to the test case. So we are given breadth and height of each envelope as in the form of 2D array. So let's go through the okay. So we are given range in form of LRI. Ranges are 5 to 4, 6 to 4, 6 to 7, and 2 to 3. For this solution, we sort this range on the basis of L in the increasing order. So now the interval are going to be sorted by L, that is 2, 5, 6, 8, 6. Now move toward how we are going to calculate answer. So in this problem, for a larger envelope, we need to put a smaller envelope, and again we have put another smaller envelope. If we have already calculated answer for J, that is for J, I have find what maximum envelope can we put outside it, and we again want to calculate answer for I. So answer for I is going to be answer of J plus 1, as and for this the breadth and height of ith need to be lesser than of jth one. So whatever answer of J is going to be, plus 1 is going to be answer of I. So this is the first thing we need to see. And for this we have already sorted this on the basis of L, and we are going to calculate answer from end. Okay, so if we have already if we have calculated answer for all the J below this, and we want to find answer of I, then for all the below J's, L is already lesser than A of I of L, as we have sorted them on basis of L. Next, we want A of all all of R need to be lesser than A of I of R. Okay. So second part need to be find, and for this, if this is satisfying, then answer of J plus 1 going to be answer of I. And for this need to maximize for all J I plus 1 till n. So these two condition need to this condition need to be satisfied for this range, and we need to take maximum plus 1. So for this we are going to use segment. Okay. So we are going to maintain a segment array of values. Okay, so going to the multiple values. So for this problem, let's consider all the R which are in our sample test, and for now assume that all other values are already present. So we have 3, 4, and 7. Okay, initially this value is going to be 0, so individually each envelope is present. Okay. Now calculating for answer for I, and whenever we calculate answer, we are going to update this segment array corresponding A of R to this answer of R. Okay, now when we want to calculate answer for this index, as we need to find, as this is storing answer of, so this segment is storing seg of I is going to be max answer where index is r. Okay, so for each r we are going to update corresponding r index with answer. So when we want to calculate answer for this, so we will need to find in segment tree a 7 plus 1 till last index maximum value. So maximum is going to be 0 and 0 plus 1 is going to be 1. So for 6 comma 7, what maximum we are able to achieve is 7. Now move to the next iterator, is 6 comma 4. And we are not updating this value into the segment tree because next L is same as previous one. So if we update the 7th index, and when we are going to calculate our answer for this, that is 4 greater than 4 till last, this 7th index is going to affected. And but these two values are same, but as per problem we need both L need to be greater than the upper one. It can't be equal, so we are not updating it. When we see any lesser value in L, we are going to update this value. Okay, so for this answer is going to be 4 plus 1, that is index 5 till last index whatever maximum value plus 1. Maximum is going to be 0. The answer for this is going to be 1. Now we are going to calculate answer for this index. For this we need to update all the answer for these two index, because now L is lesser than 6, and if we update this value and calculating answer for this L is not going to affect our answer. So for 4 the value need to update it as 1, and for index 7, that is R7, is answer is going to be 1. Okay, now when we are going to calculate answer for this, we need to find R plus 1, that is 5 till last index whatever maximum value is, that is 1 plus 1, that is 2. So what range we are achieving is this 5 to 4 and 6 to 7, as both this value 5 is lesser than 6, 4 is lesser than 7, as these two envelopes can be placed one inside other. Now we are going to calculate answer for next unit, that is 2 to 7. For this we need to find maximum 3 plus 1, that is 4 till last the max. Okay, as 5 is greater than 2, this answer need to be updated in seg array. For index 4 the value is going to be 2. Okay, as now value 1 is lesser than 2 can be updated as its greater value we are able to achieve. Now we are going to calculate answer for this. For this we need to find maximum of R plus 1, that is 4 till last. Maximum is going to be 2 and 2 plus 1 is going to be answer for this. So the range is like 2 to 3, then 5 to 4, then 5 to 4 to 6 to 7. So 2 is lesser than 5 and 3 is less than 4, and same 5 is less than 6 and 4 is lesser than 7, that is 7. So for this problem we need to return the, okay, this problem. So for this problem we need to do maximum answer envelope you can achieve. So we need to maximum, this is answer 3. So this problem answer is going to be 3. Okay, move to the next simple test case. The ranges are equal. So seg array is going to be somewhat with value 1 and other n indexes if there are any. So if we are going to calculate answer for this, initially value is going to be 0. So for this answer is going to be r plus 1 till last index, that is all is going to be 0. So answer is going to be 1. Similarly, we can't update this answer as L is same. So answer for this is going to be r plus 1, that is 1, 2 to last index. All the values are already 0. So answer is going to be 1. Similarly for this, so for this answer is going to be 1. I hope this makes you clear. Now move to the code part. Okay, so this is the segment we have already completed in another video. So seg initially all values are 0 and operation is maximum. Okay, similarly at all index max is updated. Now we calculate the build the segment tree with initial values as zeros, and we are maintaining an answer. of n. Okay, we can also maintain a variable which we take out maximum, but when we are moving from last to beginning, we need to update all the L greater than the current L answers into a segment tree. So we going to need this vector of answers of all the indexes. Okay, now this comparator is to sort the range on the basis of first index, so we sort them, and start moving from last to beginning. We are maintaining Gitche index in order to update all the ranges answer having value greater than current L. Okay, so we move to all the j greater than I. It is all the ranges above it having value not equal to current, that is greater than the current one, because values are shorter on the basis of L. So till this value is not same as the current one, we need to update its answer into the seg array at index of R. Okay. Next we are calculating answer of I. Answer of I is going to be 1 plus maximum whatever achieve R from R plus 1 to last index. And last index value, maximum value in the array can be okay, 10, 1e5. So we have created segment to 1e5 plus 5. We can also take out the maximum of this range and add plus 1. But for now, we have taken the maximum range, and at last we return the maximum of answer. Okay, I hope this makes you clear. If you have any doubt, please leave a comment. Thank you.